So I think in our previous class we looked at arithmetic operators, and in today's class we look at comparison operators. So basically, comparison operators are operators that are used to compare two values, and whenever you use any comparison operator to compare two values, the result is usually a true or a false. These are some commonly used comparison operators in Python. The first one is double equals to. You've seen the equals to earlier, and that's used for assignment. So when you say x is equals to 7, you're saying assign so for example, when you see x is equals to 7, this is an assign operator, isn't it? You're saying assign the number 7 to the variable x, isn't it? This is different from saying x equals 7, for example. When you use the double equality sign, you're saying compare the left hand side and the right hand side. Are they the same? If they are the same, it returns true, otherwise it returns false. So for example, I could come here and say is x equals to 7? This will return what? This will return true because I kept the number 7 earlier in x, isn't it? However, if I say 70, is x equals 70? No, that's false, isn't it? So whenever you use the comparison operator to compare two variables or two values, the result is usually a true or a false. And another is the not equals to. So it compares the left hand side and the right hand side. If they are not the same, it returns true. Otherwise, it returns false. This less than is a popular operator in mathematics. This is greater than. This is less than or equals to. And this is greater than or equals to. And I believe the meanings of these operators are intuitive. Please, if we have any concerns, we can indicate by raising our hands so that I can shed light. If not, I can just continue. So for example, if I have something like x equals to this sound, where is it coming from?
Let me meet the person. Because the only person that is not muted.
X is equals to, let's say, y is equals to 7. Okay? If I test x is greater than y, this will return false, isn't it? Because x is 5 and y is 7. What if I say x less than y? This should return true, isn't it? So that's how basically the most important thing is that whenever you use these comparison operators, the result is usually a Boolean. We've seen several data types earlier. Note that the double equality sign is not the same as the equality sign. This denotes comparison, while this denotes what? Assignment. Okay? We're assigning the right hand side to the left hand side, while here we're comparing the left hand side to the right hand side. Yep. So apart from the comparison operators, we also have the logical operators. The logical operators are used to extend the capabilities of the comparison operators. Life is not about yes or no, true or false, isn't it? In life, you don't just compare two things, isn't it? You compare several things, isn't it? So you can the double equality less than or equals to greater than or equals to. You can use the logical operators to extend what they can do, isn't it? And in computer science, there are several logical operators, isn't it? There are several of them, but by far the most popular are the not, and or, isn't it? The not is just a negator. It negates whatever you have. Not true. This is even intuitive. Not true is what? Is false. And then not false is what? Is true. Isn't it? So, for example, I have what's x less than y should be what? True, right? This returns true. Less than y, isn't it? So if I come here and say not, if I say not x less than y, you see this is what? This is true.
Yes.
Then not this should not be what? Should not be false, isn't it? Yeah? Yeah. Or I can come here and see. What of this? Not truth? Eh? Eh? This should be true. Because this is true. Not true is what? False. And then not false is what? Is true. It's clear. So let's look at the truth tables. The not gate is a negator, like I mentioned. It negates false to true and negates true to false. We also have the OR operator. It is true if at least one of the operands is true, isn't it? So true or false is what? For OR. False or false is what? Is false. False or true is true. True or false is true, and then true or true is true. So if at least one of the operands is true, then the result is a true. However, if all of the operands are false, then the result is false, isn't it?
So that is true carries. If logically we are to look at this, that means true carries more power.
True carries more power.
Like if one of
them. For all operator, once one of them is true, then the result is true. Even if it is 1 million true. For example, let's say true or okay, let me say or false. Okay. As much as one of them is true, the result is what? Is true. Isn't it? It's only a false when everything is what? Exactly. But if one of them, even if there are a million, that's the difference between for and. It's only true if everything is what? Is true. Even if you have 99 truths and one is what? Is false, then everything becomes false. That's what we have here. So look at it here. This false and false is false. False and true is true. True and false is true. And true and false. False and false is false. False and true is false. True and false is false, and then true and true. It's only a true when everything is true, isn't it? Yes. So for example, let's consider this example. We have x has been declared to take the number 14. And then we want to now check if x is greater than 10 and x is less than 20. So what does it do? It evaluates this first, isn't it? It also evaluate this, and then checks whether whatever we have there, we add them together, isn't it? So what do we do? In the first instance, this guy, x greater than 10, true or false? True, because 14 is indeed larger than 10. What of the right hand side? Is 14 less than 20? This is false. Yeah, correct. 14 is less than 20, so it's true. So true and true, we've seen from the table that true and true is what? Is true, and that's why we have true here. Now let's look a closer look at another example. Excuse me. We have x is 14 and y is 42. So what do we do first? We deal with whatever we have in the bracket, isn't it? The inner bracket. So x modulo 2 is what? What's x? X is 14. We know the modulo operator. So you see, the modulo operator returns the remainder. When you divide 14 by 2, what remainder do you get? 0. So is 0 equals to 0? Of course. That's true. Yeah? So this is true, isn't it? And then this is what? Also true. Okay? That's 42 modulo 3. That's the remainder is also 0. So this is also true. So what happens? Excuse me. True and true is what? True. Is true, isn't it? True and true is true. And then not true is what? Is false. I think everybody gets this now. Good. So that wasn't very easy to read, was it? Is there a way we can make it more readable? So if you like, you can just take it step by step. But I think once you get the logic, you can be able to maneuver them however you want, isn't it? So we look at strings. We looked at strings earlier. We said strings are any variables that are enclosed within the quotation mark, isn't it? It could be single quotation or double quotation. Yeah. For example, we have a string here: x hyphen y rocks. When we apply the plus operator on strings, what does it do? It concatenates, isn't it? Yes. So if we without this, if we add x and y, we have Python rocks joined together. But if we want them to be separated, then we add this particular string at the middle. So we have Python rocks. And of course, we can also multiply string by an integer, isn't it? If you say x times, if x is a string and you say x times 3, it's just like saying x plus x plus x, isn't it? And that's what we have here. We have x to carry the string. If you have, you have x is Python. Okay. We know we've learned earlier that we could say x plus x, isn't it? That will be Python, isn't it? If we add another one, it will be Python, isn't it? So, but mathematically, x plus x is what? It's 3x, right? So you can say 3 times x. And that will give us the same thing. So you could also say 300 times x, and then we'll get all sort of. Okay? So this can be is the variable x, and then repeated is y, and then when we do this, x, which is this can be, plus some space, here, and then repeated, that's from here to here, multiplied 3 times. So repeated, isn't it? Is it clear? It's clear? Good. So the most interesting thing about strings is that we can apply what we call methods on them. Methods are essentially functions that you apply on strings. In Python jargons, we call the functions that we call from methods declared instead of, well, this beyond the scope of it. But let's see, functions that are declared inside of a class are called methods in Python, isn't it? And whenever you create an instance of a class and you want to call such methods, such functions, you call them methods, and you use the dot notation to get them. So look at it. Here is a function upper, and here's another one lower. Where do we get this from? These are string methods, meaning they are functions that you can apply on strings, isn't it? So for example, we have the string Edinburgh kept inside of the variable x, and then we now say x is x of upper. We are asking Python to convert the string Edinburgh to uppercase. When we have university of as a string kept inside of the variable y, and we call the lower method, we're asking Python to convert every variable in the string x, rather y, to what? To lowercase. Let's try it. So let's say we have x is Python, isn't it? If I say x dot upper, and I run this, you see that Python has become capital letter, isn't it? If I do the same, it becomes I love programming in Python, isn't it? If I do lower here, it says I love programming in what? In Python, isn't it? If I do dot title, title case in format document in document formatting, only the first letter of every word is capitalized, isn't it? So here we have I love programming in Python, isn't it? We also have capitalize. Okay. It says in capitalize it's only the first letter of the sentence that is capitalized. It's clear. Now somebody may ask, where do you get all these capitalize, upper, lower, etc. from? Well, if you want to have the complete list of all the methods you could call on a string, the function is dir. Okay, dir, dir. Okay, so if you do dir str, you get a comprehensive list of all the methods you could call on a string. Can you see them?
ST what?
The str. The str should be italicized. It should be in. Even if you run it without the quotation, it will work fine. So these methods that start and end with double underscore, we call them special methods, okay? Yeah, because they are special, and we will not treat them here. They are beyond the scope of what we treat here. They are mostly useful in object-oriented programming. For now, we are going to restrict ourselves to methods that do not start and end with double underscore. And you can see a comprehensive list of them arranged alphabetically from capitalize, casefloat, center, count, encode, entry, expand tabs, find, format, etc. Well, it may not be practical for one to, because this is just a 4-week class. So I will not treat them one after the other. But I will show you a way in which you can know what it does. Because I've been using Python for quite some time, so once you call a basic method, I should know what it does. For example, if you say start with, remember, what are these? What are all these? What are all these guys? They are string methods. String methods. String methods. What does that mean? They are methods that can only be applied where? On strings. You cannot call a list in Python and say list.upper. It doesn't make sense, isn't it? Because .upper is not a list method. It's a string method. So you can only apply those methods where? On strings. So for example, if I say, what's x? I love programming in Python, yeah? So if I say x dot ends with, yeah? If I say O, for example, what am I doing? I'm asking Python to check whether the string x ends with an O, isn't it? So it ended with an exclamation mark, so it returns false, isn't it? However, if I put exclamation mark here, it returns what? It returns true. I could also check that on starts with. Okay? And this will return false, but if I put O here, it returns what? True. What do you think if I put capital I here? Will this return true or false? False. Why?
Because it's a very small letter.
Yeah, because Python is case sensitive, isn't it? Python is case sensitive. Capital I is different from small I. Good. So how do you, for example, you want to use replace in your code, and you've forgotten what it does. Will you go to Google and search for how to use replace? No. Within the Python interpreter, you can be able to get the documentation of how replace works, isn't it? And how do you do that? Help, isn't it? You can say help in small letters. Help. What? str dot what? Replies, isn't it? If you want this, you have a documentation that says, okay, replace. It returns a copy with all occurrences of a substring old replaced by what? By a new, isn't it? So look at it. You supply in two things. Two numbers. The old and the what? New. And you get a substring where every occurrence of old is replaced by what? By a new. For example, let's see, let's call x. What's x? Let me replace love with what? No. O. The word O with something. I can say x dot replace. Please, wherever you see an O, replace it with the what? With a K. So it says what? Can you see? Wherever there's an O, it is being replaced with what? With a K. Or I can put A here. If I run this, it says I leave programming in what? Python. Any question?
The string function x dot capitalize.
I'm coming, please. I'm coming. Sorry, buddy?
Yes, I said they use that string method.
Yes.
Capitalize on that and left one bracket.
Okay, yeah. when I did dot upper, dot lower, dot capitalized, no? Yeah, that's the, they are, I said they are functions, they are methods, sir. And your methods are functions. And in Python, whenever you call any function, you have to call the bracket, isn't it? Just like we've been using print, no? If you call print is a function now.
Yes.
So as soon as you call print, what do? You open bracket and close it, isn't it? Only that sometimes we put something inside the what? We put something inside the bracket, right? Maybe I can put 5 here, isn't it? Hmm? Or maybe if you call length or len, let's say x, len is also a function. So since it's a function, as soon as I call len, I open the bracket and close it, isn't it? Only that maybe I supply something. So it's customary in Python that whenever you call functions, you open the bracket and close it. But some functions do not require you to add any parameter. They are parameterless, isn't it? So in that case, you leave it empty, isn't it? But you have to put it. Is that clear?
So this print is not like when we started with Python, I personally thought the print was a universal function.
That's correct. It's an inbuilt function. That's the
when you want to direct it
to print something to a screen.
Yes. Yeah. It's print.
That's correct.
Okay.
So what we're saying is that the dot upper, that dot lower, dot capitalized, they are no different from print. So since we use open bracket and close bracket on print, yes, we will have to also use that on any
function.
Yeah, just to. So it's just exactly.
Then I noticed something when this function the replace. Did everything just come together? Like when we have like x is equal to I love programming in Python. Are we using the same? What do we call it? The box. Is it on the same box that we
No, it doesn't matter. You can do everything in one place. I can come here and say, I can say here, y is equals to, Python is a cool programming language, okay? And I can come here and say, y dot replies wherever you see t, put what? What do you mean? Which alphabet is more prominent here? Let's see A, isn't it? Make it what? L, for example. Okay. Is that okay? Come and print. So you can decide to. You can do it either in one cell or in different cells. Okay. Okay. Okay, didn't. Okay. Replace. Exactly. Any question? So let's continue. So these are mixing numbers, multi-line. In Python you can also write multi. How do we comment stuff in Python? Hash, isn't it? We use hash to comment out a statement. So whenever you precede any code with hash, you are telling the interpreter to ignore that. You shouldn't bother interpreting it. And if you want to do multiple lines, you can just use the triple quotation. Whenever you have triple quotation, okay, let's say you have 1, 2, 3. So whatever you put here, even if it spans multiple lines, Python will assume that they are what? They are all strings. Yeah? Is that clear? not clear. It's not clear. What's not clear? If you want to do one line of string, she is a single quotation or double quotation. So what if you want the string? If the string is many, you will have to be coming one line after the other, isn't it? If you want, the lazy way is to come and do something here, isn't it? Then another one, yeah, Abi?
Yes.
Then another one. But that's lazy. That's cumbersome. It takes time, isn't it? That's laborious. Why not you just do something like this? 1, 2, 3, sorry, and then you freely write whatever you want to write. It's clear.
So just 3 particular.
Yeah, 3, 3. 1, 2, 3, 1, 2, 3. And then you write whatever you want to write in. Okay. So I expect you to go through all the other methods. There are quite a number of them. And then you play around with them. What are they used for? You can even write some simple codes to just invoke the methods to see what they do and how they can be manipulated. Yeah? So this is another way you can print. We've been using printing earlier, isn't it? So for strings, we have to enclose them in equation. For numbers, which we ignore the. So this is a quick quiz. Do you see anything wrong with this block?
Yes.
What's the problem?
7.
Hmm?
76 is nice.
Sorry? Hmm?
76 is nice string.
76 is not a string, and it is not allowable to add strings and numbers. So if you want this, how can we ameliorate this? Can we solve this problem? You can cast.
You cast.
Yeah. You can just add str. Yeah. So you can simply cast, isn't it? Or we can, if you don't want to cast, you can simply do it in different places, well? String 1, string 2, string 3. We also have.
If we do it in different places, so we'll do.
It is separated by comma. String 1 is a string.
Yes.
str1 is a string.
Yes.
Another value. So once you call the print statement and you separate the variables with comma, even if they are of different types, they are printed, but there will be space in between them, isn't it? So there is also another way to interleave numbers. There is the F command that we usually use, but most importantly is the format statement. The format. You know, if you go back to the state when we list here. Can you see it? It's also a string method. So what's the usefulness of the string method? Format. It allows you, no, that's not the format. For example, let me come here and say, let me say name is equals to Yusuf. Okay? And let me see, age is equals to 98. Okay, is that okay? If I say print dash is dash, watch here. Watch here. I said name is what? Age. I now printed something and I put it inside the quotation. And here you can see a curly bracket, isn't it? There's another curly bracket. So here you're saying, please, I will supply in a value here. Oh? I will supply in a value here, and the value is going to come from the format function or method. So if I say dash is dash years old. If I say dash is dash years old. If I say dot format, if I say whatever should come here should be the first variable here. If I say our name, whatever should come second here should be the second variable. I can say age. Okay. So around this, it says Yusuf is 98 years old. You understand? What do you think will happen if I interchange this? If I put age here and I do something like this? You say 98 is Yusuf years old, isn't it? So this basically how we use the format method, isn't it? So this can be used maybe in programs where you have no control over the variable that's going to be printed, isn't it? When you write a flexible program in which you do not have control over what's going to be printed. So in that case,
so different names can come, different ages.
so for example, I can say, let me write a simple program and say, okay, let's see, name. I say name is equals to input, enter your name, okay, and I say year of birth, yeah? I see enter year of birth, okay. Okay, and I see age is equals to 2014 minus 2024 and 2025, good, minus into what? Year of birth, isn't it? And I say print hello curly bracket, isn't it? You are now dash years. Okay. So this is a simple program that asks a user to enter his name and also to enter his year of birth, and then the program returns a statement telling him his current age, isn't it? So you can see that whatever we want to print here is not static, it's dynamic. It depends on what the user enters. So if I run this now, I can just call dot what? Dot format. What should come first? Name. And what should come next?
Yeah.
The age, isn't it? So if I run this now, it says enter your name. I say my name is Yusuf. Enter year of birth. I say I'm born in 1976. it says, hello Yusuf, you are now 49 years old, isn't it? If another user enters, says, what's your name? Says, her name is Zainab. She is born in 2000. Say, hello Zainab, you are now 25 years old, isn't it? And so you see, this only made possible using the what? Using the format, method, isn't it? So it makes our code more elegant and easy. So look at it, we also have this dot format that tries to format the way in which the decimal point appears, isn't it? If you add this, you can see that it's returned in what? In one decimal place. So and then this is what is going to be kept here, isn't it? Yes. So commenting, we said we comment using what? Using the hash symbol. So the recap is that we looked at variables, types, arithmetic operators, Boolean logic, strings, printing, and accessories. So any question before we go to lists? Or should I give classwork that we can just practice now? Eh? Before the classwork, let me reintroduce this input statement. This input statement is a function in Python that allows user to what? To enter something. It allows user to enter something. For example, if you say x is equals to input. If you run this, it requests you to enter something, but whatever you enter is kept inside what? Inside x. However, the type of x will be what? Is a string. Are we together? Yes. So if you say x is equals to input, you can optionally write a statement inside the input so that the user will enter whatever, will see whatever he is asked to enter. Enter any number. Enter any number. If you run this now, what happens? The user is requested to enter any number. Whatever he enters is going to be kept inside what? Inside x. So if you come here and you say x plus 22, what will be the value?
No. Because
only my
78 is
a string, so it will not. So that's why whenever you're using the input function, you have to be very careful. Because sometimes you can use the input function to accept numbers. So in that case, you have to cast in order for you to perform further arithmetic operation. So please, your classwork is just to classwork. Let me write it. Write a Python code that requests a user to enter his or her UTME and PUTME and return and print out the what? Your program should print out the aggregate. How do you spell aggregate? Aggregate. Isn't it? Let me call this we're writing a Python program. Let me see, double asterisks. I need to do this. Okay. So this is class work. Who has finished? Classwork. This is Q1. This is Q2. Write a pattern program that requires user to enter the radius and the height of a cylinder You're done? The second one. Finish the second one, please. That was what I thought. What I have written that in the slide, huh? I said that's what I have here. So if something is not clear, stop me and ask. So yeah. Madam?
So I've been having error. I said UTM square is equal to infinity.
Okay, let's do it together. Let's do it together.
Yes,
So let's see. For the first one, no?
Yes.
You can see UTME is equals to input.
Enter your UTM square.
Enter UTME score, isn't it? Have you?
Yes.
In fact, I can just come here and say int, isn't it? Or float. Okay, if I want to convert that to. Okay, I can see the aggregate score is what? Is UTME plus put name divide by 2, isn't it? I can say print. I see aggregate. Aggregate score is what? AGT, isn't it? Have you? So if I run this now, if I run this, if I put 230 and I put 211, see what? Aggregate score is what? Aggregate score is it's clear now? Yes, I put 201, then 198, 190. Aggregate score is what? 190. For the other one, it should be what?
Radius of cylinder.
R is equals to float float, input, enter radius, isn't it? Then height, we input enter height, what? Huh? I can now say what? I can say print. I can say volume is what? Pi is what? 22 over 7. Times what? Times R times what? Times H, isn't it? Times R times R squared, what? Times what? Times H, isn't it? Doesn't matter, isn't it? So you can just come here and say what? Print, the volume, the volume of a cylinder with radius of what? And the height of is what? Is that okay? Then dot what? First one will be what? R, go. Then H, then what? V, isn't it? Is that okay? So I can come here and say, basically 2, 4, and then you said the what? The volume of a cylinder with radius of 2.0 and height of 4.0 is what? 50 point. I run this now. I see 32. This is 23. Is that okay? So we'll stop here.
So I guess like for me, where I made a mistake was the float. I didn't add any float. I just said impute.
Oh yeah, because
so I now said aggregate.
Yeah.
That's
So
where
you know,
I was now trying to now convert everything.
Okay, it's possible. That's also great.
So I now put integer that's int.
That's, yeah, if you want to do it like that, you can just come here and see what. So you can just remove this and remove this, well. Understand? So you don't want to get confused. You can just come and say R is equals to what? Float R. And then H is equals to float what? Float H, isn't it? Is that okay? And then you can now run this, isn't it? So you can just do it like that.
Or you must do it like this.
No, this is another way. Meaning you get the value of R first using input. You get the value of H using input. Yeah? And then you know they are now as strings. Then you now separately cast them in different lines of code before performing any arithmetic operations on that particular. Exactly.
Oh, sorry, it's the only float that we can use.
No. It depends on the practicality of the radius. The radius can be decimal.
Okay.
If you write the code to only be integers, then it can be problematic. But there are instances in which the value can only be, for example, if I say each, that can just be int. For example, enter your year of birth. You cannot be born in 1995.2. Is it possible? No, it's either you are born in 1995 or 1996. Even if you are born in 31st December 1995, your year of birth is 1995. Even though it is 1 second to enter. So I think at this jump.
Lastly, can can it work this way if we say print, then float, brackets, so that we now know that everything is now float? Will it work? Because that's what I first tried to do.
Yeah, at this point?
Yes. It's like print.
No. The reason why we cast is to enable arithmetic operation. These are problems. Here we are saying 22/7 times r, and r is a string. So these are problems. It's not the printing. For print, it doesn't matter whether it is a string or a float. But we only cast to enable us perform arithmetic operations on the variables that we have collected.
Okay, lastly,
Yes.
the division that we did at first.
Yes.
I was thinking if we are dividing, the division sign is not okay. The division sign slash or
Yes.
oh, shit. Then which one is the one that the common percentage?
Modulo.
Modulo, yes.
Modulo is percentage.
Okay.
Percentage is modulo.
In programming, the modulo is percentage.
Percentage is modulo.
What does it?
Remainder.
Okay.
Five.
Okay, that's why.
5 modulo 2.
Wait,
When you divide 5 by 2, what's the remainder? 1. So
One.
it gives you 1.
Okay. Start. It's a matter of time. Yeah.
This one is special program.
Okay.
That is why I do not ask until when I enter the class.
Okay. So we meet what time tomorrow?
2 o'clock by the way.
Please, can we be having this? Can we be having the recording?
Yes, it's in the group now. The last one was there.
Just the slide.
It's also in the
In the
group.
group now.
And you do not say.
Tomorrow morning.